Okay, class, in this video we're going to find the area inside of two polar curves. So here's the question. So find the area inside of both r equals cosine theta. We should know that's a circle centered on the x-axis. And r equals sine theta, that's a circle centered on the y-axis. So this is what the picture looks like. R equals sine theta is the circle here. R equals cosine is this circle. And the shaded part, that's your region. Okay? So I'm going to blow that shaded region up and draw another picture. Okay, so here we go. So this is what this region looks like when I blow it up. And what do you notice? So basically, I have an intersection somewhere right around there, and we'll calculate that in a second. So essentially, I have two things here. I have an area 1 there and an area 2 there. Okay, now remember we talked about how dr is supposed to go. Dr is supposed to go radially out from the origin. So in region 1 there, in area 1, basically, I hit the sine curve, but I don't hit the cosine curve. And for region 2 there, for area 2, if I were to go radially out, I hit the cosine curve, but I don't hit the sine curve. Okay? Now, we're in the first quadrant, so it's reasonable to assume that we're integrating from essentially from 0 to pi over 2, but it's going to be two separate intervals because I've got two different regions. Okay? So to figure that out, you would just to figure out the intersection point, we just set our functions equal. Okay, and you can remember what that answer is, or you can make a tangent, so divide by cosine and make a tangent. So theta would be pi over 4. And once again, it has more answers, but that's the first quadrant answer that we're looking for. So that's where these two regions meet. So if I'm going to write the area, my area is going to be 1/2. Okay, so essentially I have to do this in two parts. So from 0 to pi over 4, it's going to be the sine curve. And don't forget to square things. Okay, but from pi over 4 to pi over 2, it's going to be the cosine curve. Oops, pi over 4. Okay, now, of course, in this particular case, we have symmetry there. Those regions should be equal. So really, if you just took this 1 and doubled it, that would give you the same answer. Okay, so let's look at one where you can't really do that. Okay, so we're going to find the area inside of both. What do we got here? R equals 1 minus cosine theta and R equals cosine of theta. Alright, so this is something we should be able to do all this, set up everything by hand. Once again, we're not evaluating stuff. I feel like we've done enough of that. But in this particular case, you should be able to set it up by hand. I would say, you should even be able to evaluate it. It is kind of long, so I'm not going to bother to do that here. But I'll tell you that frequently these are things that would be on a calculator. So if you didn't know what these curves look like, you'd use your calculator and figure that out. Okay, so what does it look like? So this is a cardioid, and I'm going to kind of draw it in an exaggerated way, just so we can sort of see everything. So this is a cardioid, looks something like that. It's pointing to the left. It's cosine, so it's x-axis centered. And then this is a circle that's positive x-axis centered, so it's going to look something like this. So notice that I've got two pieces here. I'm just going to focus on one. Okay, so I'm going to focus on this piece right here, and notice if I draw a line there where they intersect, I'm going to have two separate regions. So on the left, I'm dealing with something that's the cardioid, and on the right, I'm dealing with something that's the circle. Okay, so like before, we need to find that intersection point, and we do that by setting things equal. Okay, so let me just step back and say, if you're having to find this on the calculator, what you really need to do is just write your equation down, maybe even put everything on one side. So that would be 1 minus 2 cosine theta equals 0. and then sketchograph that, but not in polar mode, in function mode. Okay, and I'd say the same thing with evaluating an integral. If you're going to evaluate this integral on a calculator, it needs to actually be in function mode. And you're going to change all your thetas to x's when you put it in your calculator. All right, so what do we get? We get basically, if I move the cosine over there, we're going to get that 1/2 is cosine theta. And I feel like we've done that enough to know that that means theta is pi over 3. Okay, so that's where they meet. And once again, this area here is going to be in the first quadrant. So how would I set everything up? So my area is going to be 2, because I'm just finding the 1 region, and we're doubling it to get this one down here. And then 1/2, the integral from 0 to pi over 3 of 1 minus cosine theta squared d theta. So that's the area inside the cardioid. That's the first part. And the other part is inside the circle. So plus 1/2 the integral from 0 to, not 0, pi over 3 to pi over 2. And that's the circle cosine squared theta d theta. And there we go. That would be your area for that particular region. All right. That's it for polar curves. Yay.